Welcome back to Social Data Analysis. In our previous video, we learned matrices, and it would be pretty nice to know how to apply matrices to some real life examples and how to analyze data in matrices. So we're just going to go through some basic steps of what you can do with matrices. And as time goes on, whatever you learn in R generally can also be applied to matrices. But let's have a glimpse of it, shall we? Take some data from the real world and convert them into matrices. Remember, we had this data from a survey about about three tourists that visited some African countries, and they rated their satisfaction levels. If I run everything from our previous lesson, what we get is a matrix that is sort of a data set here. We can use this data for our example today and learn about some basic analysis that you can run using matrices, right? So let's get into it. Now, one thing that you can do with a data set like this is you might want to know what is the general impression that tourists have about these countries in Africa. So what we can do is we can find the average of each satisfaction level for the cities in Africa, and then it gives us the general idea of satisfaction levels for that particular city. Now, each of these cities represents a column, so we can find the mean or the average for each column, and automatically we get the satisfaction level that these tourists have for these particular cities in Africa. In R, the function we use for calculating column means is called call means. It's very simple, so you might remember it each time off head, but if not, you can always search it as I've taught you. Now with call means, we can find a satisfaction level for each city if we pass the data set into this function called call means. Let's go ahead and create an object called average satisfaction, and in this object we would assign our satisfaction data, which is satisfaction matrix here, to call means. Right now, the reason why we are assigning everything to the data set but we're still going to get only the average of columns is that this function specifically operates on columns. So if we pass the entire data set to it, it's just going to operate on columns because it's a function made for just finding the average of each column. If we run this, we get the average satisfaction level for each African city. We know that overall, these tourists are more satisfied with Accra, which is in Ghana, and they're also satisfied with Kigali in Rwanda. And I think Cape Town here has the highest satisfaction level, which is in South Africa. So this can at least give some tourist guidelines on which African country will probably be the best for them to spend their next vacation. We can also find the satisfaction levels overall. Overall, how do these tourists see these whole countries put together? So it's sort of like the average for the entire satisfaction levels, and then we can easily do that with a simple function called mean, right? So mean just gives you the average of everything else, and the name of the function explains itself. With mean, we can just name an object called overall average and pass to it the entire data set once again, right? We pass the entire data set to it again, and then we call overall average the general impression or the general satisfaction level of these African countries. Now we have 3.5 or 3.6, depending on how you run it. Just with this, we're able to know how overall people are satisfied with these countries they visited. If we were supposed to do sort of like an intercontinental analysis, we can look at how satisfied tourists are with maybe cities in Africa as compared to, let's say, Europe or North America or South America and things like that. But with this, we have an overall impression of the satisfaction levels of these tourists. We can also find which countries meet a certain threshold. So, for example, if we were operating a tourist agency and then we said, well, countries that rate higher than 4.0 are the best countries you can ever visit, then we can use a threshold and use a logical condition, right? Using a Boolean data type to find out which African countries meet this threshold that we can recommend to new tourists coming, right? So to do that, we can store the value of our threshold, which is the number 4, for example, in an object called threshold. So this object is going to be a placeholder for the number 4, and then we're going to pass threshold to our data to find out which cities in Africa meet our threshold. Now, because we are interested in which cities in Africa meet high satisfaction levels, we can name the object high satisfaction, right? It's always good to name the object something that you can easily relate to and remember. And we can pass to it our data set as well as our threshold object and say which cities in Africa is greater than this threshold. So we can call our data set satisfaction matrix and say we want cities in Africa that exceed beyond this threshold, right? Now, because we saved the number 4 in an object called threshold, all we have to do is to use the word threshold and say, give me every city in Africa. Now, because we saved the value 4 into a threshold object, we can just use the threshold object and say, give me all satisfaction levels that exceed beyond the number 4. Now, let's call high satisfaction. As usual, I'll type the name of my object once again and run everything and see how it goes. Okay, so what we see here is a Boolean data type or a logical data type saying true or false. Now, true means that these tourists rate these African countries as exceeding 4.0 in terms of satisfaction levels, right? So we can see that for Rose, Nairobi in Kenya and Kigali in Rwanda are the best cities for her, right? In terms of our threshold. For Portia, Accra, Ghana, and Cape Town was the best for her in terms of our threshold. Now we have an idea of which cities in Africa are the best for some of our tourists, and we can use this data to advise new tourists that will be coming to us for recommendation. Now, this is just a glimpse of what you can do with matrices. As time goes on, I'm going to be introducing new functions and new analysis, and you can always apply these to matrices. If you enjoyed this video, please like and subscribe. It helps us to reach a broader audience and more people are able to see this channel and learn about data analytics. See you in the next video. Bye.